So, bonjour, ça va? Salam, kemelahi, kemelaha, здравствуйте. Как поживаете? Bonjour, guten Morgen, Ohio, ni hao. I'm sure there's a couple other ones in there.
I recognized Ohio.
Cleveland rocks. All right. So let's say good morning. So good morning, good morning, good morning. I'd like to welcome everyone to our webinar on decoupling architectures like there's no tomorrow. My name is, actually, before I go that far, I'd like to thank you all for joining us and spending the next hour or so. My name is Stephen Cole. I'm the AWS certification specialist at Cloud Academy, and I have actually one cert just expired. I had 7, so now technically I have 6 active certs. I have to go back and take that one again. And with me today is Will Meadows.
I'm Will. I'm a senior AWS trainer and content makey person. I also have some certs, not as many as Stephen though, and I think many of them are expiring because I've been too busy to go get retested on them. But today we have a really fun and hopefully educational lecture about how to decouple your stuffs, specifically with AWS.
Yeah, I'm really excited about it. I mean, one of the things that we can, part of it is just understanding why it's important. I want to remind everybody really quickly that we are going to record, that this webinar is being recorded, and we will share it via email as soon as it's available. There is a little chat box. Please feel free to put in whatever questions. We'll collect them and try to answer them at the end. You can see the agenda on the screen. I'm going to let Will drive, and actually, I'll let him present. So take it away, Will.
Yeah. All right. So when we think about our conversation we're going to have on decoupling things, we have to understand first what tight coupling is. And then we're going to talk about 3 services that will help us relieve some of this tightly coupled pressure we'll have on our architectures. And then we'll think about ways to move forward in the future with possibly discussing some serverless and microservice approaches to doing more of the same, of trying to remove the complexities in our huge monolithic systems that we may or may not have or have thought about building. So I guess that means we should probably start with what does it mean to be tightly coupled? In general, it means that all of your components, as you see here on the slide, are really linked together. One thing references another thing references a third thing, and God, if one thing was to fall apart, the whole system would fly off the wheel and break and hit the walls. In general, that's probably a bad thing to do for a large-scale production environment or an enterprise software. So as we go through this talk, we're going to try to poke at these sore spots and give you ways to sort of get around them.
I'm sorry, I don't mean to interrupt. I was just going to say, this is a lot of what we're looking at in on-premises architectures. You buy a box, you put all the software on them, and that means if something breaks, like if you update the operating system, you have to turn everything off, you have to reboot everything, something goes wrong during the day. There's a lot of things, a lot of moving parts that are all connected, and they're all in the same place.
And it can be really easy as you first start creating or experimenting, where you've built a solution that maybe you have management pressure, that people say, all right, just go from there, and you start tacking more and more onto your design, your architectures. And if you don't take a moment to make sure that they can be independent and fail independently and scale independently, it really hurts you later down the line. So how about we go ahead and take a look at some of these solutions that we're going to provide you, or options, I should say. So these are the 3 services, again, that we're going to talk about: the Elastic Load Balancer, the simple queue service, and the simple notification service. Everything's so simple here. But let's start off with the ELB. So if we take a look at this architectural diagram, you'll see we have a web tier and an app tier, and all of our traffic is coming through DNS. Let's say we're example.com, everyone's favorite website. And if all of this traffic is pushed through your system and it's hard coded into your, let's say your web, and it's hard coded into your app that all that information is going to go straight to the database, it can be very difficult if any one of these links in the chain fail, because again, if you've hard coded it, this is going to have sort of upstream / downstream effects for any data that's trying to get to that, say, specific web server that's broken, and that maybe could kill the entire web tier with some maybe no reference exception problems. So if just one thing in this tightly coupled example in the app tier goes offline, it could affect your entire web tier. And that's
And
bad.
this happens a lot too, because people, when they first put their workloads in the cloud, they basically mirror what they have on premises. They have a system that's always on, it's always running, and they just basically make a copy of it and put it in the cloud. And everything is super tightly coupled because that's the way it's been working on premises, and it's always worked that way, and it's always been great because they don't actually have to pay attention to turning things off and on, because everything, when it's in the on-premises data center, those costs are hidden from you. The paying for the networking and paying for the storage, it's just running, it's just there. You've already paid for it and nobody cares about it. So when you put it into the cloud and you just lift and shift, you just copy it up there, it seems like, oh, I'm going to get all these cost savings because it's now in the cloud. And the trouble is, it isn't, because that's not how the cloud really works.
Yeah, exactly. And one other thing we could probably think of is like, what if we wanted to add something to the app tier? Like what if we wanted to scale? And if we were doing this by hand, we'd have to shove in a new instance into that group. And God, we got to go back over to the web tier. Maybe we have to change the HTML or whatever your back or your front end is using, and point to the new app tier over here. Like this is starting to get messy. Look at all these lines. Lines are bad. That's the thing I want you to take away from this talk. So what's
Lines
one
are
way
bad.
we can easily remove some lines from this architectural diagram? Boom, ELB. It already looks simpler, right? What is the point of ELB? What does it do? This is the elastic load balancer. It'll help you move traffic from, if you see the front of the architecture, DNS straight over to the web tier. And from the web tier, it'll help us have one point, one sort of source of truth of where all traffic will go from the app tier. So the web tier points to ELB, the ELB knows where all the things are on the app tier and points it directly. And if, let's say, you were to add something, that's only one additional link in the chain that's very easy to manage.
And on top of that, when you add that link, you're not actually adding it to your code. You're not actually adding it to the web tier. The web tier doesn't care. It points at that new load balancer. The load balancer is now aware of a new endpoint, and it just starts directing traffic as needed. So it basically makes our lives as systems architects, systems administrators, solutions architects, it makes our lives easier because it's one less set of hard-coded things I have to add anywhere.
And actually, I was just thinking about it. This may not be something, if you're new, that's come up to you a lot, is you can put the Elastic Load Balancer internally to direct traffic between the web tier and the app tier. It's something that can come up quite often, actually. Good to know. Here's the other nice thing about ELB. You don't have to manage it. It's an AWS managed service. It's extremely hard to knock down. I think what is the SLA is 99.99% as I got there. So it's, even with a bunch of load on this system, it's something that you will never have to worry about. And it's something that you can just put out of your brain for architecting your solutions.
Yep, and they can be public and private, so you can hide them inside your architectures so that they're totally invisible to the outside world. You can have them publicly facing so that they can point at like your web tiers. But again, if you want to manage internal processes with a load balancer, they don't have to be seen by the outside world at all.
And in this situation, if this, similar to before, if this web server was to go down, we're not going to really have any downstream effects from this. In fact, ignore that. In fact, ELB is paying attention to these web servers, is doing health checks on them, and as soon as it detects that the connection is no longer valuable, valid, or on, or any of that sort of stuff, it will no longer worry about it. It will check that target group that the ELB is listening to. And if you had an auto-scaling group, this application can become self-healing. It will put a new instance in its place, and it will relink it back up to the ELB. So that's pretty nice. But here's the question. What do we do if this goes down? What if we've got this whole system, we've got our ELBs in, but if the database is down for a moment, isn't that going to kill everything? Are we still tightly coupled? That's a good question. That's one I would ask. So I want to move on to SQS. Stephen, you want to tell us a little bit about it?
So, Amazon Web Services has a lot of services that are named simple. And the idea behind simple services are that they do one thing and one thing only and really, really, really well. And a simple queue service is as it sounds. It was the original Amazon Web Service. Before it was Web Services, it was the Amazon Web Service, and it was SQS. And this would give you the ability to put requests into a queue that would just wait as long as you needed to for a consumer to grab them, process them, and send them on. So if your database were to go down, for example, if you needed an always on connection for your database, and we know that it's not a matter of if a database connection will fail, but it's when it will fail, why not put something between the application that needs the data and the database itself, so that I don't always have to worry about that database connection being up and active all of the time. So SQS, the simple queue service, allows you to put requests into a queue and then have something else pull it out. Slow and steady wins the race, or it could be faster depending on how big of an application that's reading the queue. And this allows you to now feed your database in a way that will maximize the use of that database. So you don't actually have to have the biggest, fastest database on the planet. You have a queue processor that's going to pull data out of the queue and put it into the database, and or make requests from the database. I'm going to put something into the queue that says, hey, I need some data. And this way we can manage the connection and make sure, and we don't have to actually have to have it on all the time. It can be ready, and when it's, I mean, it can be up, when the queue is, we can fill the queue as needed, and the database can run the process. And if you need to restart the database or do something to it, the queue fills up and then the database comes back online and we finish the process.
And one of the nice things when you think about these queues, if you have a lot of these consumers that are pulling from it, is how do you deal with making sure that they don't pull from the same object? So let's say you have a queue of 100 things, maybe you have 101 producers. How do you make sure that 101th doesn't get a copy? Well, all of these things that are in the queue, when a consumer goes to retrieve it or to eat it, gets locked in a visibility timeout. This is something that's very important to know, especially if you're looking on the test. And this visibility timeout makes sure that no other processes can poke that thing until it unlocks itself, in say in 45 seconds. And the object or the entity in charge of that is the consumer itself. It will go back and say, I've completed my task, this thing is done, and then it can be removed from the SQS servers. Another cool fact about SQS, again, is it's more on the managed side, is it distributes your message across multiple servers. I always thought that was really neat. Like there's no one server that could go down that you would lose your entire queue. It's a distributed system like a lot of Amazon's, I'd say all of Amazon's products. So let's take a look at what that might appear to be in action. So this one's a little bit more of a detailed diagram because I think it's got some interesting stuff. So we have our ELB here on the left side that you can see. And we have traffic either coming from DNS or whatever into our web store here in the front. And again, this could be multiple servers. So this is in your public subnet, accessible to many. And in here, let's say you were navigating Amazon.com and you wanted to press that ship button or that complete order button. That would send a message over to our orders queue, and that would stack up in there. And of course, if our processing part of our pipeline is on, it can just take those orders right out of the queue, shove them into a database. It can do whatever it wants with it, which is super nice. But if our database is down, those orders can just stack up in the queue and then can be reprocessed later when we have the capability to do so or the bandwidth to do so. And one of the other very fun things I think about the service is it allows you to utilize, if you're using instances, spot instances very well. So let's say you have that system that is down, that database, and you need to catch up. You could spin up 100 spot instances at a half of the price, quarter of the price, a tenth the price, it depends on the time and wherever, to quickly negotiate through that queue and burn through all of the collected wood that's gathered there. And then you can just have those instances go away. And it's sort of a one-time expenditure to catch up. And a lot of the times it will be cheaper than have just running it straightforward in the first place. Use spot instances, that's the real thing I want to get to. So there's a couple different types of queues that are important to know about. We have the standard queue, which is kind of like what we've just been talking about here. It's got an interesting mechanic. It's guaranteed to have at least once delivery. So if you put a message in there, you will definitely get it at least once. You may also get it 5 times. So your application kind of has to deal with that on its end to make sure that that order has been processed. So maybe you'd use an order number, but that's the fun part. So remember, at least once delivery, but maybe 5. You know, it could be 6, could be 2. And then if oh yeah, an order is not guaranteed with the standard queue, so you may get them out of the order that your users brought them in. So if order is important, we recommend use a FIFO queue, which processes each thing exactly one time. We guarantee there will only be one instance of it, and it will get in the order that you demanded it. But it does have a problem of 300 messages per second, but this can be increased through batching, where you can go up to, I believe, 3,000. Maybe it's been changed recently, Stephen, if you have any information on that.
You know, I don't remember the exact number, but yeah, FIFO or FIFO, first in, first out. So we guarantee, or you pay a little extra to get, and it will put the order numbers in there, like a sequence number, into the queue for you. And that way, instead of you putting those numbers in there to try to figure out if they're in order or out of order, you can use the queue's ordering, the queue sequence number for processing.
And if all of that sort of fails, like if you had a message that had like a garbled JSON text that was hidden deep within it, and your poor, order processing instances are trying their best, but like they've gone through and tried to process that order 5 times and failed each time, that information can be thrown into a dead letter queue, which can then be analyzed later by you or one of your techs to figure out why is it that this isn't making it through the system. So that's another, that's like the third variety of queue, is the dead letter queue.
Yeah, the dead letter queue is a nice way to basically troubleshoot maybe what went wrong. So maybe you have, instead of an EC2 instance, maybe you're running some Lambda functions, and your Lambda functions aren't sized, don't have the right size. So it's taking too long. Maybe you make the visibility timeout queue 10 seconds, and it's taking 12 seconds for the process to happen. And so now what's happening is that the visibility timeout is expiring, another queue processor is looking at it, you're hitting all kinds of contention. Now I can, eventually it'll fail hard and drop into the dead letter queue, and you can say, oh, it's taking too long. I can now run against it and test it. So nothing will be lost. You get to keep all of the pieces, and you can try to redo it at a later time or troubleshoot what's been happening.
Another interesting thing I want to point out for those of you who are going towards sort of architectural is that the queues actually live out here in the regions. They're not directly associated with your VPC or availability zone or anything like that. So if that ever comes up on a test or a trivia question, that's a good one to know. Alrighty, now you might be wondering, I talked about that scaling thing. So you can scale based on the queue depth. There are a couple ways to do this. This is the one that I recommend because it's the one that Amazon recommends, which is you want to come up with an ideal amount of backlog in your queue. And we're going to have that ideal backlog versus like the current backlog is what our metric is going to be. And so basically it says you find the approximate number of messages that are currently in the queue. This is an API call, you can ask it. You divide that by the current fleet capacity that you have, and that is the current backlog per instance. Now to get our acceptable backlog per instance, you get your acceptable time in a queue. How long can I let this message hang around in cyberspace? Let's say 10 seconds. And then you divide that by the time it takes to process that message. Let's say it takes 1/10 of a second. So you would know that your acceptable time in the queue, your APBI, would be about 100 for the acceptable number of things that could be in there. And you might notice that if our queue depth got to 1500, the current number of messages divided by the fleet capacity, which is 10, I've got a little 2x here for the instances, would be 150. So now is the time to scale, and an approximate amount to scale by. So cool beans, I like that. All right, so we've talked about SQS, we've talked about ELB. Now I want to discuss SNS here as a way to sort of distribute your messages out to people. Stephen, you want to take this one away as well?
Sure. So, we have a queue. So maybe you're having you have a request, or you're going to put data into the database, and it kind of fills up the queue and it sends data to the database. But what happens if you have actions that have to take place? Some sort of transformation on the data, or you need to let other services know that there's some data available, or you need to allow other things to happen. People, somehow a system needs to be aware that things are happening. Maybe there's reports you want to run when certain events happen, whatever it is. So SNS, the simple notification service, again, simple, it does one thing really, really well, and that is send notifications. I can create what's called a topic, and I can publish, I can send something to that topic. And you can think of it as like your text message. It works similarly. I'm just going to send a broadcast out to something, in this case, to a topic. And if I'm listening to that topic, if I subscribe to that topic, I'm going to be made aware that something happened that I should pay attention to. Now, the size of the queue is the SQS queue is the exact same size as the SNS topic. So when I put something into an SQS queue, I can have one of my consumers of my SQS queue put something into a topic. And if I subscribe to that topic, I can send a notification to Lambda to run a function. I can put something into a different queue. I can send a text message. I can send an email message. I can update a website. I can trigger a lot of events. And this allows me to fan out from a simple set of transactions to a larger, wider scale system. For example, if I wanted to run a report, or I want to encode some data, or I have some video or some images, I can now, rather than depend on a very large single monolithic system, I can now spread that out. And if I want to add a new piece later, all I have to do is subscribe my new piece, my new microservice, my new EC2 instance program, whatever's running on that instance, that server, or anything. I can subscribe to that and trigger another event.
I think you can see then with the addition of SNS with SQS, you can start to see how it allows us to build distributed systems that don't necessarily have to rely on each other in the moment. They can relax and sort of deal with things at their own pace. I think one of the important ideas with decoupling is taking your monolithic programs and breaking them up into chunkable parts that can scale independently of each other and can fail independently of each other without breaking the whole thing down. So with that in mind, I like this architectural diagram. This is sort of a real working example. Imagine you had a website with where users add images, maybe it's like Reddit. And what that website needs to do is generate a thumbnail for that thing, generate a size for the mobile, and generate the size for the web. So let's say the user has their pug, right, or French bulldog, and they say, you know what, we're going to go ahead and upload that to the website. So the website would take that, and maybe it shoves that into an S3 upload bucket. And then from there, you can use SNS, a topic is used in the situation, to listen. It's an upload trigger from S3, and push a notification to all of these little queues you see here. And it can add a message into that queue. And as described earlier, we could have auto scaling groups and instances waiting and checking the length of that queue to see if they want to add more spot instances. Maybe there's a high threat or a high number of people uploading right now, or it could scale down to help deal and chug through this queue that's being built. And then all of that can get pushed over into, I'm gonna move my window so I can see, another bucket for maybe download or redistribution out to the web, which could be pushed to CloudFront and to your users on the inside.
Yeah, and the other neat thing is that auto scaling group say that, so one of those three pieces, the generate thumbnail, size for mobile, size for web, maybe you have three different teams, and maybe one of them likes to write all of their code in Java, and the other one likes to write all their code in Go, and the other one loves Python. You could let those three teams build these things independently, and all we're doing is asking for the information from the SNS topic. So as long as I get the right data, who cares what your development system is, as long as it works for you. And then if you decide to shift tomorrow, oh, we're all gonna standardize on I can't, like, Fortran. Okay, maybe not Fortran. Maybe that's the wrong answer. But maybe tomorrow we're gonna start working in Python, and we want to do the next version, Python 8, 3.8, 3.9, something like that. So whatever the choices are, you can now, these are all independent. You can do them as you need to. All you have to do is subscribe to the topic.
It's very powerful. It's using these sort of this trifecta of services together in the right way can add and leverage a lot of technology to your advantage. So we're getting towards this idea of sort of encapsulating our things, our logic, all of our systems, and breaking them apart. And that's where you start getting towards microservices. And if you're thinking microservices, there's many routes you can go, but I highly recommend you check out serverless. It's not always the most cost effective, especially if you're dealing in huge transaction volumes, because you can get extreme amounts of saving using spot instances. But what it does offer you is like compute on demand. Maybe you only get your compute, one time or sporadically throughout the day, or maybe you just have a tiny little startup and you don't want to deal with managing any type of server nonsense whatsoever, especially if your code's very encapsulatable. Thinking serverless, thinking Lambda will really help elevate your architectures that direction. And Lambda does have some problems. It only runs for 15 minutes and it doesn't retry very well. It doesn't do if-then statements particularly well. It doesn't do parallelism particularly well. So a service that will help you solve that problem is to use step functions with it. It's a state machine, think of a vending machine, and it allows you to do all of those things with Lambda in a nice cohesive way.
Exactly. So like for Lambda has a bunch of SDKs that you can use, and when you decide to write your code, and you do need that if-then statement, or you need to have a process that says, well, I have a transaction that's got 3 pieces, right? And all 3 have to succeed, or all 3 fail. So if one of them fails, that all 3 have to be backed out. I can use step functions like a state machine, let all 3 work, and then put in some logic that says, oh, the second half of the transaction didn't finish. I need to back those all out. So I can create large scale machines without ever having to provision a server or set of servers to manage my architecture. Because I mean, and this is something that I try to put in almost all of my beginner training materials, is that that the cloud in many ways is like my father. Now, my father is of a man of a certain age that would get upset with me when I was a kid if I left the room and left a light on. Like, if you leave the room, turn the light out, close the door, I'm not heating the neighborhood, or I'm not cooling the neighborhood, whatever it is. So AWS, the cloud, is designed to scale as you need it, but you get the best cost effectiveness when you turn things off when you're not using them. Servers are expensive. If you leave them on all the time, you're going to get a bill. When you're on premises, you're going to get a bill. You're just not going to necessarily see it. Somebody sees a bill, but they're not, that cost has been paid. But in the cloud, you're going to get a bill if you leave something on. So if you turn it on, remember to turn it off. If you spin it up, if you make it bigger, every now and then you have to make sure that it shrunk. Elasticity, scaling, it lets you grow bigger. Elasticity lets you shrink to minimize costs. In serverless, which is a nice thing here, is that we have to change a little bit of how we think about our data. Always on gets us in trouble because it's expensive. Always on, always connected is expensive, and it's brittle. It just will break. Not a matter of when, it's a matter, not a matter of if, it's a matter of when. So how do we get rid of the brittleness of that always on connection? And using queues, using SNS topics, using Lambda functions, serverless, using stateless spot instances where I don't care about the state of the exact of the data. I just want a piece of data, I want to process it. Once we have those things, we can start to turn off the always on things. We start to save money, and we start to allow us to optimize individual components of our servers. Maybe something runs too long in the middle. Maybe it could be more secure. Maybe somebody needs a copy. Oh, I can give access. So serverless and microservices are part of the natural evolution of moving to the cloud, of taking that big always on machine that's on premises and breaking it into a bunch of little pieces that you still have to keep track of. You still need to know what's going on, but you can now take it apart and turn it off when you're not using it.
That was a fantastic wrap up. I'm glad I had you do that. I don't think I could have wrapped it up as succinctly as you did. And that kind of does bring us to the end. This is just a touch shorter than we usually do, but We really do appreciate having you all here, and I hope you all learned something.
Well, we have some
And
questions.
we do have some questions. I was hoping
We do
we
have
would
some
get some.
questions. Uh, so in advance, we had somebody ask about what would your strategy be for decoupling an existing distributed monolithic architecture? I mean, I have my opinions, but what are yours, Will?
Oh God, start so slow. Go find the easiest thing you think you can whittle away from the tree of sadness, and go have some developer, maybe even the junior, work on trying to make that an independent function that has well documented APIs that can be tested from externally. And then you can try to do a quick swap over. Maybe you send 20% of your traffic to that baby microservice, and if it takes it, then you can start switching over to that gently. Um, Start small, start with something you can complete, and that will make you happy when it's done.
Exactly. I mean, you're gonna when you move over, it's going to be expensive. I wish it were not true. I wish that were wrong. But if you do a lift and shift, it's going to be more expensive than you expect. So start small because otherwise, I mean, you don't want to break a production system. And sometimes it's if you're going to start small, what you could do is add some new functionality so that you're not going to take away from the old, and you can learn some lessons from that. I found some success there. Um, the other thing I think when it comes to distributing the monolithic architecture is especially if you're a solutions architect, a systems administrator, and maybe you've heard the term API a bunch of times. If you don't really get it, if you've not really played with it, you're going to be struggling a little bit. So find a programming language. My language of choice for such things is Python because I can do a lot of system administration with it. But once you start working with objects and you understand what an API is and you can actually feel what that feels like and why that's important, then you can start to see like, oh, this is the connection. This is where I'm going to start to glue things together. So pay attention to those things and really start to appreciate like the value of that API, that contract that's the thing that's not going to change. The values that go from one place to the other, I don't care about the code underneath. There was a generic question about stateless apps, microservices, and functions as a service. I think we kind of covered it in general.
Yeah.
But somebody asked about the cost benefit ratio when decoupling a cloud architecture. Um, Now, personally, I think that it's hard to talk about because it just depends, right? It depends on how big things are, it depends on what you're doing. But overall, what you see is the ability to turn things off when you're not using them and save money. The other piece of that is you need to reimagine what it feels like to be distributed, meaning that not everything is going to be updated in real time all of the time. So you have to be ready for data to be a little stale. You have to be ready for data to be updated every 10 seconds, 15 seconds, 1 minute, 10 minutes, something like that, so that you have realistic expectations.
I think
Is part of it too.
on the
Go ahead.
cost side, you can gain some cost benefit if you're scaling your entire monolith equally. Obviously, you're leaving some compute on the table because you're probably overscaling. The nice thing when you break up your architecture into little microservices is you can scale to the effective need of that part of the system, and you don't have to scale the whole system as a whole. I repeated. Oh, you don't have to scale the whole system for each of its parts together. So it's something to think about.
So there was a question about behind the elastic load balancer, and basically there was a question that says, is it true that the ELB can abstract the connections, but it only works if the components are of all the same type? Now, this I think was true in the classic load balancer because it will auto balance, it'll rebalance as needed. It used to be with the classic load balancer that whatever you put behind it, you needed to make sure that all of those instances were of the same type and shape and size. But now with the application load balancer, because you can have, oh goodness, I forget the application groups, is that the right?
Yeah, target groups.
Target groups. Now with target groups, you can actually send traffic to containers. You can send them to individual instances. You can send traffic to different processes running on the same machine. So there's a little bit more give and take. It means you really need to understand your application better. Will, do you have thoughts about that?
Yeah, it's a little bit more agnostic. It doesn't care so much. And uh, it also depends on how you're scaling. So you can scale your auto scaling groups on CPU load, network throughput. You can scale, like I showed you, on queue size. So it depends on what your metric is as well. But in general, yeah, I mean, if you're using the application load balancer, it kind of just shoves your traffic off in a direction and expects it to be caught over there and dealt with.
There was somebody that brought up a question about RDS proxy, and RDS proxy is relatively new. If you're not familiar with it, don't be surprised if you're listening like, what the heck is this thing? We don't have a ton of architectural diagrams in the wild right now because I think it was announced at last reInvent. After a while, I mean, this COVID thing, I'm trying to remember what happens yesterday. But what you can do is you can put a proxy between your application, the database application, and the database itself. And it's a middle layer that will kind of forward connections and take care of some of the back end for you. It is another decoupling mechanism, but it requires a slightly different architecture, and meaning that if you're going to try to decouple, it's going to be, you're really not decoupling. You're basically putting a layer in there, like it's not really a cache, but you can kind of think of it like a cache. But it just sits there and it connects to it and forwards the connections as needed. And probably a webinar for another day. Somebody asked, what response would the user get if the database is down and they ran a query and that query connected to SQS?
What response would the user get if they ran a query? I'm sorry, can you repeat the question?
So it's kind of a trick question. It doesn't really have an answer. So it's, if you make a request, if the database is down and you ran a query and you were using SQS. So if you're, the thing is, if you're trying to run a query, a pure query, then what you're doing is you're trying to connect the database and run this thing. That's not what SQS is going to do. What you're going to do is you're going to make a query in your application. You're going to send a programmatic request somehow to that SQS queue. That SQS queue is going to ask for something, or it's going to have some sort of payload in it. And then a consumer is going to do the work for you on your behalf. If the database is unavailable, that consumer is just going to sit and wait because there's nothing for it to do. It's going to pull, then it's going to try to reach out and do something for you, and it's just going to do nothing until the database is available.
And that's why, like in this architectural diagram here, I didn't even put the database there because it's irrelevant as far as it's concerned. In our private subnet here, the processing thing, the processing setup is just going to wait until the database is online, and then it will start chewing through the queue to quickly get as much information to the database as possible. And if it goes off again, it will just wait. So that's a nice setup to have, where though the database is offline and that sucks, it will all be taken care of eventually.
Let's see, how do you manipulate the dead letter queue for troubleshooting? Well, it's just a queue. And what you're going to do is you go to that queue that is getting nothing and you look at what's in there and you try to figure out why it's not working. You can run it, grab the data by hand manually, which is never a good thing, never ever. So you can maybe look at it programmatically, see if there's an error message when it times out. Is there a timeout problem? Is the data misformed or malformed? That just depends on the application. I mean, your dead letter queue is only going to get the payload so that you can definitely process it. It just sits there until somebody does something to it. Simple queue service, simple queue service, does it contemplate the existence of a sort of an exception queue or to log the item on the consumed? I'm not 100% sure what this is asking, but my guess is that if you have an exception, like if you were to maybe, say like, totally different topic, only because I've been researching it. Say you have Kinesis, and you're trying to send something with Kinesis, and you get this error message that is an exceeded throughput, or sorry, consumed throughput exceeded exception. What could happen there is where do the error messages go? And I think that's a different type of question because it depends on the consumer. So if it's a Lambda consumer, it's going to do certain things and put information in CloudTrail or in CloudWatch logs. If it's an EC2 instance, your exceptions are going to probably show up in your EC2 instance, which means you're going to want to grab those logs. If you're shutting them down before you shut down an EC2 instance, you want to make sure if you're going to terminate them, you want to make sure that you grab any application logs or you send them out to another service, whether it be CloudWatch logs, CloudWatch in general, something like that. Do you have any other thoughts on that, Will?
No, I think that was very well put together.
Somebody would like kind of a repeat of what you talked about where the queue sits, because it's even here in your diagram.
Yeah.
Why does the queue sit outside of the VPC?
That's where Amazon put it. You know what would be funny? I don't know the exact answer, but if I was to speculate, maybe even VPC didn't exist when SQS was around, because it was the first service, right?
That is correct.
So it might not have even been a thing for it to think about back then. But it is something important to know for a test if one was to take one.
Correct. It is a service that sits outside of the VPC, but you can still protect it with your IAM policies. You can encrypt data that you put inside the SQS queue. Now you cannot encrypt like the FIFO queue. You can't encrypt the sequence number, because you got to be able to read it. You got to know what number it is, but you can encrypt the payload using KMS or other tools depending on how you want to use it. But yeah, it just sits outside of it's provisioned on your behalf by AWS. Let's see. What would be the best way to know the various services in detail, like ELB, SNS, SQS, etc.?
I recommend if you ever find a cool service you like, write it down, and then pick a day that you want to do your learning. A little bit every day is always good. And what I usually do is I will go immediately to YouTube and just try to go find the AWS release video that they either did at reInvent or Summit or whatever, and I'll watch that at like 1.5x speed. And then go to the FAQ question section for the service on the website for AWS, and that will answer some surprising questions you never knew you had or would ever think to ask. And that will tell you more about the service than you can really glean from the docs, in my opinion. The docs will tell you how to use the thing sometimes, but I find the FAQ tells you a lot of why to use the thing and other people's use cases.
Exactly. So like for me, there's a couple things. One is at one point I needed to learn about DynamoDB, and who on earth learns from their success? Who is successful and thinks I learned a lesson by winning the race? No, you don't learn a lesson from winning a race. You learn the lesson by losing or coming in second or failing spectacularly. So what I did was I had to learn DynamoDB, and so I created a DynamoDB database and I tried to put data in it and I failed. And then I finally got data in it, and then I tried to find data and I failed. And so finding a little project that you have, something that you want to keep track of, and it could be simple. It could be, hey, I want to put in an address, make an address list or an address book, and I want to be able to look up by phone number and I want to look up by last name. So now you need to learn how to get the data in. You need to figure out how to get the data out. You need to figure out how the data gets sorted, if it gets sorted at all. You need to figure out how you can create an index and how do you search that index. And it can be painful, but because it hurts, you don't forget these lessons. So I would say start with what Will did. Say, oh, I want to learn about ELB. And then after you figured it out, build one, put it together, try it from the console, then try to do it from the command line, send data through the ELB, send an error message, try to break it. Because, you know, breaking things is fun. Breaking things is fun.
Yeah, that is the funny part about AWS is you can learn how all the things are supposed to fit together, but when you actually go on the console and try to build your first sort of architectures by hand, you will really understand the pain that you may be asking somebody else to do on your behalf, because some things are not always as intuitive as you'd imagine, or are just well documented as you imagine. And only by doing the building yourself will you get the full ramifications and the understanding and the deep knowledge that's required to really get good at this stuff.
Last thing that I see here is just kind of a reiteration of the SQ outside of the VPC. And so somebody had asked about the where it sits. So not just why, but kind of where. And so it sits, there's a couple services that are just Amazon specific. They're Amazon only services. These are not things that you provision. So they just sit outside, they're in the region. As long as you can get to that region from wherever your services are, you can see the service that's been provisioned for you. Hang on a sec. So let's see, any other parting words, Maestro?
Just like learning with all things, do a little bit every day and do a little bit of reading every day, and all of this stuff will start to mingle really well together. If you're looking for more information on building decoupled architectures, go and systems like that, I would go poke at understanding the ELB and the application load balancer really well. I would understand how Lambda can function by itself or with step functions. Maybe go poke at containers, because they can also be part of a very well decoupled architecture or part of microservices very well. So I don't know, I guess in short, you can do it. I believe in you. And
I have faith. I have faith. You know, and then I guess the other thing for me is that, and this even showed up kind of as a question at the last minute, APIs and microservices. So an API, think of it as a contract, right? That's how AWS thinks about it. When they create an API, which is just, how am I going to receive this data? I'm going to make a request, and the application programming interface, whatever, I'm going to send that data from one program to the other. That data, I don't care what's on the other side. I just want that data to be processed. The microservice itself is the small piece that does whatever you want it to do. And so when as you build these decoupled architectures, you want a bunch of little microservices, ones that don't impact everything else. If you want to think about it, here's another way to consider it. I mentioned that the simple notification service is simple because it does one thing. It sends notifications. The simple queue service does one thing. It manages queues. The simple storage service does one thing. It stores data. The simple storage service doesn't do DNS queries. The simple storage service doesn't manage SQL queries. The simple storage service doesn't do provisioning of EC2 instances. It does storage. So that's what your microservices should do. If you have a microservice that generates thumbnails, then that's all it should do. Don't make it do two things. Make it do one thing, and then have us run that as many times as you need it to do the thing that you need, whether they be formatting a text string, encoding video streams, or something else. I can't think of anything. So have your microservices do one thing really, really well. And then if you figure out a better way to do it, then all you have to do is change one microservice and not 10 of them.
That's the real value of APIs, is everything downstream from you just has to keep hitting the same, the same URL for the same API with the same variables, and it should get the same response back. While internally, you could be manipulating, destroying, creating, and whatever to your microservice, and externally, everything's fine.
Exactly.
And that's because it's decoupled.
Yeah, take it apart, put it back together, or leave it alone and then build a new one and try to swap it out and see what happens. So So you have possibilities here. And like Will said, I have faith. I have faith in everyone listening to this that they can do amazing things. With that, I think we're going to go back to that thank you slide. Will, thank you very, very much for being part of this with me.
Yeah, thank you.
And want to remind everybody that you will get a copy or get a link to this recording as soon as it's available. There is a Cloud Academy LinkedIn group. I'm starting to try to post things there. If you have questions that didn't get raised here, you can find me there, or you can find me on LinkedIn directly. Send me a message. I will respond to you at my earliest convenience. I tend to got my hands full writing content, but I always like a distraction. There is a survey. Please fill it out, because if you tell us what you're interested in, we could give you more of that. If you don't tell us, we don't know. So I'm here to help. Will's here to help. Cloud Academy is here to help you become successful, take over the world, just like Pinky and the Brain.
Yeah, what do you
And
want us to ramble about for 30 minutes to 45 minutes? That's the real question.
yeah, love to find that out. And so please take a few minutes and let us know. With that said, again, thank you, Will, and we will see you on the internet somewhere.
Bye, everybody.